Hello and good morning, everyone. Today I am going to discuss each item's correct answer from our midterm examination in linear algebra. Beginning with number 1. Find the determinant of a 2 by 2 matrix whose entries are 1, 2, 3, and 4. I think this is a 2 by 2 matrix, and the determinant of a 2 by 2 matrix is computed using the formula AD minus BC, which gives us 1 times 4 minus 2 times 3, and that is equivalent to negative 2. So the correct answer is letter A. Number 2, if matrix A rather is equal to 1, 2, 3, and 4, does the inverse of A exist? The correct answer for this question is letter B, which is no. This is because a matrix has an inverse only if its determinant is not 0. So if the determinant is 0, the inverse does not exist. So 2x plus y equals 5 and x minus y equals 1. The correct answer of number 3 is letter B, because solving the system gives us x equals 2 and y equals 1, which corresponds to the ordered pair 2 and 1. Number 4. Solve x plus y equals 2 and x minus y equals 0. The correct answer for number 4 is letter B. Solving the equation results in x equals 1 and y equals 1. So the correct answer is 1 and 1, which is letter B. Number 5 question. Two matrices can be added only if. The correct answer for number 5 is letter C. This is because matrix addition requires matrices to have the same dimensions so that corresponding elements can be added. Number 6 question. If AB is defined, which must be true? The correct answer for this is letter B. This is because matrix multiplication is defined only when the number of columns of the first matrix equals to the number of rows of the second. So the correct answer is letter B. Number 7. If A is 3 by 2 and B is 2 by 4, what is the dimension of AB? So the correct answer for number 7 is letter A. The resulting matrix from multiplying matrix A, which is 3 by 2 and 2 by 4 from matrix B, results in a 3 by 4 matrix as its dimension. Number 8 question. Which property is not true for matrix multiplication? The correct answer for number 8 is letter C. Matrix multiplication is not commutative, meaning AB is not equal to BA in general. Number 9 question. If A is identity, then AX equals X implies the correct answer for number 9 is letter C, which is X is unchanged. The identity matrix leaves any matrix unchanged when multiplied. Number 10 question. If matrix multiplication is not commutative, what implication arises? The correct answer for number 10 is letter A, which means order matters. And also because matrix multiplication is not commutative, the order of multiplication matters. So the answer is letter A. Number 11, a zero determinant implies A. Invertible matrix, B. Full rank, C. Singular matrix, D. Orthogonal matrix. The correct answer for number 11 is letter C. It's because a zero determinant means the matrix is singular and has no inverse. So the answer again is letter C. Swapping two rows changes determinant. The correct answer is letter C, which sign changes. Interchanging two rows changes the sign of the determinant. So that's the reason why the answer is letter C. For number 13, which are we now? What number are we now? We are in number 13. The question for number 13 is, determinant of triangular matrix equals A. Sum of diagonal, B. Product of diagonal, C. Difference of diagonal, and letter D. 0. The correct answer for number 13 is letter B. The determinant of a triangular matrix is the product of its diagonal entries. The product of diagonal again. Number 14 is, if determinant is 0, system is A. Consistent, unique, B. Consistent or infinite, C. Always infinite, and letter D. Always consistent. The correct answer for number 14 is letter B. It's because if the determinant is 0, the system cannot have a unique solution and is either inconsistent or has infinitely many solutions. Again, the correct answer is letter B. For number 15 question, a system with no solution is A. Consistent, B. Inconsistent, C. Dependent, or D. Independent. The correct answer for number 15 is letter B. A system with no solution is called inconsistent, or letter B. Number 16 question, unique solution occurs when? Among these choices, the correct answer is letter B. This is because a non-zero determinant guarantees a unique solution. So that's why the answer is letter B. 17 question. Row reduction leads to, among these choices, the correct one is letter D, reduce row echelon form. This is because row reduction leads to reduce row echelon form, which simplifies solving systems. Number 18 question. Pivot is A. First non-zero entry in row, B. Determinant, C. Column sum, D. Diagonal entry. The correct answer for number 18 is letter A. A pivot is the first non-zero entry in row. So the answer is letter A. Number 19 question, which matrix is always invertible? Among these choices, the correct answer is letter C, which is identity matrix. This is because the identity matrix is always invertible because its determinant is 1. Number 20. A teacher presents a system of equations whose augmented matrix reduces to a row of the form 0, 0, 5. What should students conclude? Among these choices, the correct answer is letter C. It is because a row like 0, 0, 0, and 5 represents an impossible equation, so the system is inconsistent. Number 21. A student claims that if two matrices have the same determinant, they must be equal. How should the teacher respond? Among these choices, the correct answer is letter B. The teacher should say incorrect. Determinant does not uniquely identify a matrix. This is because equal determinants do not guarantee equal matrices because different matrices can have the same determinant. Number 22. A teacher asks students to compare solving a system using inverse versus Gauss-Jordan. Which is most valid conclusion? Among these choices, the correct answer is letter B. Gauss-Jordan avoids determinant computation. This is because, as what I've said earlier, Gauss-Jordan avoids determinant computation by using raw operations. Number 23. We are now in number 23. The question goes like this. A student reduces a matrix to echelon form but stops before identity. What method was used? Among these choices, the correct answer is letter D. This is because stopping at echelon form indicates Gaussian elimination, not full Gauss-Jordan. So the answer is letter D. 24th question, which situation guarantees a matrix has no inverse? Among these choices, the correct answer is letter D. This is because all listed conditions, it could be non-square, that equals 0, rank is lesser than n, prevent a matrix from having an inverse. Therefore, the answer is, for number 24 is letter D, all of the above. 25th question. A matrix is both diagonal and symmetric. What additional property must it have? So among the choices, the correct answer is letter C. A diagonal symmetric matrix must have entries only along the diagonal. So letter C is the answer. It is only for diagonal entries. Number 26. A system's augmented matrix has a pivot in every column except the last. What does this imply? The correct answer for number 26 is A. It's because having pivots in all variable columns leads to a unique solution. Number 27. A student computes day a to the power of t. What is the correct relation? The correct answer for number 27 is letter A. The determinant of a transpose equals the determinant of the original matrix, which is letter A. Number 28. A teacher wants students to identify computational efficiency. Which method is least efficient for large systems? The correct answer for number 28 is letter C. Kramer's rule is inefficient for large systems due to repeated determinant calculations. So the answer is letter C. Number 29. A teacher asks, why is determinant important in solving systems? The correct answer for number 29 is letter B. Determinants help determine whether a matrix is invertible. So letter B is the answer for number 29. Number 30. A system has three variables but only two pivot positions. What does this indicate? Number 30 answer is letter B. It's because fewer points than variables indicate free variables, leading to infinitely many solutions. Again, the answer is letter B. Number 31. Let A and B be non-zero matrices such that AB equals 0. Which statement is necessarily true? Among these choices, the correct answer is letter C. This shows a one-sided inverse, not a full inverse relationship. So the correct answer is letter C. Both are singular. We are now in our number 32 question. Suppose A times the quantity of B plus C equals AB plus AC, but the quantity of A plus B times C is not equal to AC plus BC in a student's work. What is the most likely error? So the correct answer for number 32 is letter A. There must be a misuse of distributive property because in this case, the answers must be equal. So the problem there is the misuse of distributive property. Number 33, if AB equals I but BA is not equal to I, what can be concluded? So the correct answer for number 33 is letter C. This is because this shows a one-sided inverse, not a full inverse relationship. So B is inverse of A only on one side. Number 34 question, which expression is always symmetric, regardless of matrix A? Among the choices, the correct answer is letter D, which is both B and C. So the option B and C always shows a symmetric regardless of the matrix A. Number 35 question, if A is invertible, which statement must hold? The correct answer for number 35 is letter A. This is because a matrix multiplied by its inverse equals the identity. So the correct answer for number 35 is letter A. Number 36. Given A equals 2 minus 1, 3, and 4, and B equals 15 minus 20, find 2A minus B. So this simply subtracting the B matrix from A matrix and then multiplying it by 2. Or simply distributing 2 times A and 2 times B, and then the result will be subtracted from the 2A. So applying the property or the distributive property, the correct answer for number 36 is letter B. Number 37 question. Given A equals 12 minus 34 and B equals 0 minus 152. Find AB. The correct answer for number 37 is letter C. It's because proper matrix multiplication results the answer from letter C. Number 38 question, given A equals, or matrix A equals 1, 2, 3, and 4, and matrix B equals 2 minus 105, find AB raised to T. The correct answer by applying the right formula is letter B. After adding and transposing, the result matches option B. It's more on like adding and then transposing. Number 39 question, let matrix A equals 2, 0 minus 13 and B 4, 1, 2 minus 2, find A raised to T plus B. The correct answer for number 39 is letter C. This is because adding matrices entry-wise gives the result in option C, which is 6, 2, 1, and 1. Number 40 question, subtracting. The question goes like this. Let A be 2, 1, 0 minus 1 and B equals 2, 4, 3, 4 rather 2, 1. Find AB minus BA. So this simply multiplying A times B and then multiplying B times A as well, and then the result from BA will be sub is going to be subtracted, or the result from BA will be used to subtract the AB. So the correct answer for number 40 from the choices is letter A. Number 41. Solve x plus 2y equals 4 and 3x plus 2y equals 12. The correct answer for number 41 is letter A. The system simplifies to one intersection point, so it has a unique solution. Number 42 question. Solve x plus y equals 2x plus y equals 5. The correct answer for number 42 is letter C. Identical questions represent the same line, giving infinitely many solutions. Number 43 question. Using matrices, solve x plus y plus z equals 6, 2x plus y plus z equals 7, x plus 2y plus z equals 7. The correct answer for number 43, applying the formula for finding this system of equation, is letter D. So any method can be used in number 43 in order for the right answer to be found. Now we are in our number 44. If a system reduces to 1003010 minus 2001 and 5, the solution is, the correct answer for number 44 is letter D. The reduced matrix directly reveals the solution values. That's our 44. Number 45. After Gauss-Jordan, the matrix becomes 102401 minus 130010. The system has A. Unique solution, B. Infinite solutions, C. No solution, or letter D. Exactly two solutions. So the answer for number 45 is letter B. A zero row indicates dependency, giving infinitely many solutions. Number 46. A system reduces to 100, 2010, 1001, and 7. The conclusion is A. Unique, B. Infinite, C. No solution, or D. Trivial. So the right answer for number 46 is letter B. Three variables imply infinitely many solutions. Number 47. Which operation is not allowed in Gauss-Jordan? A. Swap rows, B. Multiply row by non-zero scalar, C. Add multiple of row to another, or letter D. Multiply column. So the right answer for number 47 is letter D. It's because column operations are not allowed in Gauss-Jordan elimination. Number 48. If a pivot column has all zeros except pivot, what does it imply? A. Free variable, B. Leading variable, C. No solution, D. Redundant equation. The correct answer is letter B. It's because a pivot column represents a leading variable. Number 49. A system reduces to identity matrix. This means A. Infinite solutions, B. No solution, letter C. Unique solution, or D. Singular system. The correct answer for number 49 is letter C. This is because reducing to the identity matrix means a unique solution exists. Number 50. If one row becomes all zeros, it indicates A. Inconsistency, B. Redundancy, C. Unique solution, D. Determinant equals 1. The correct answer for number 50 is letter C. Or letter B rather. A row of zero shows redundancy in the equation. So letter B is the right answer for number 50. Number 51. Which form is required in Gauss-Jordan? A. Upper triangular, B. Diagonal, C. Reduced row echelon form, or letter D. Identity only. Number 51 right answer is letter C. Gauss-Jordan requires reduced row echelon form. So the right answer is letter C. Number 52, a pivot in every column of coefficient matrix implies A. Infinite solutions, B. Unique solution, C. No solution, or letter D. Rank deficiency. The right answer for number 52 is letter B. A pivot in every column ensures a unique solution. 52 is letter B. Number 53, the inverse method is applicable only when A. Matrix is rectangular. B. That A is not equal to 0. Letter C. That A equals 0. Or letter D. Matrix is diagonal. The correct answer for number 53 is letter B. It is because the inverse method requires a non-zero determinant. Number 54 question, solve using inverse. There would be application of inverse method in this system, which is x plus y equals 5 and 2x plus y equals 7. So applying the inverse method, the correct answer for number 54 is letter C. Or solving gives the ordered pair in option C, which is 1 and 4. Number 55, if ax equals b, then solution is... So the correct answer for number 55 is letter C. The correct formula is x is equal to a inverse of a times b. Number 56 question, if that a equals 0, inverse method, A works normally, B gives infinite solution, C cannot be applied, D gives zero solution. The correct answer for number 56 is letter C. If the determinant is 0, the inverse method cannot be applied. Number 57, which is true about inverse method? A always fastest, B no matrix needed, C works for all systems, and letter D requires determinant not equal to 0. The correct answer for number 57 is letter D. The inverse method requires a non-zero determinant. Number 58 question. If the inverse of A exists, then A is singular, B A is non-singular, C that A equals 0, and D A is 0. The correct answer for number 58 is letter B. A is non-singular. It cannot be that A equals 0 or A is 0 because it the inverse of A cannot exist if that A is 0 and A is singular or the A is 0. So it should be A is non-singular in order for the inverse of A to exist. Number 59 question. If a system has no inverse, it has likely A unique solution, B always none, C always infinite, D infinite or no solution. The correct answer for number 59 is letter D. Without an inverse, the system has no solution or infinitely many. Letter B. Number 60 question. Kramer's rule applies when A matrix is rectangular, B that A is not 0, C that A is 0, D matrix is triangular. The correct answer for number 60 is letter B. It is computationally heavy for large systems. Kramer's rule applies only when that A is not zero or determinant is non-zero. Sorry, had the explanation for number 61 rather than for 60. So again, Kramer's rule applies only when the determinant is not zero, which is found in option B. So number 60 is letter B. Number 61 question. Kramer's rule uses A. Row operations, B. Inverse matrix, C. Determinants, D. Eigenvalues. The correct answer for number 61 is letter C. It uses determinants. Kramer's rule uses determinants to solve systems. Number 62 question. Which is a disadvantage of Kramer's rule? A. Not accurate. B. Computationally heavy for large systems. C. Cannot solve linear systems. Or letter D. Only for non-square. The correct answer for number 62 is letter B. It is computationally heavy for large systems. 63. If all determinants in Kramer's are zero, then it has A. Unique solution, B. No solution, C. Infinite or no solution, or D. Trivial solution. Number 63 question is letter C. Zero determinants lead to infinite or no solution. Number 64. Kramer's rule is best suited for A. Large systems, B. Small systems, C. Nonlinear, or D. Rectangular. Number 64 question is letter B. It is best suited for small systems. 65 question. Which determinant is replaced in solving for x? A. First column, B. Second column, C. Last column, or D. Entire matrix. So the answer for this is letter C. So determinant in solving for S. So the determinant to be replaced in solving for S is the last column. Number 66. If in Kramer's rule the determinant of the coefficient matrix is non-zero, but the determinant corresponding to one variable is zero, what can be concluded about that variable? A. The system has no solution. B. The system is inconsistent. C. The value of that variable is zero. And D. The system has infinitely many solutions. Looking into these choices, the correct one is letter C. It's because if a variable's determinant is zero, then that variable is equal to zero. Simply as that. Number 67. Evaluate 2, 3, 4, and 5. So by evaluating this matrix, the correct answer is letter A. It gives us -2. Simply applying 2 by 2 matrix. Determinant. Number 68. Evaluate 1, 0, 2 minus 1, 3, 1, 2, 1, 0. The correct answer for number 68 is letter C, which is -7. Number 69. If A, B, C, D equals 6, find 2A, 2B, and CD. So multiplying 2 to A and to B, the correct answer is, from these choices, the correct answer is letter B, which is 12. Number 70. If a row of a determinant is multiplied by 3, the determinant becomes A same, B triple, C 0, or D half. So if a row of a determinant is multiplied by 3, of course, the determinant would become tripled. Because, of course, multiplying by 3, then obviously it would be tripled. Number 71. If two rows are interchanged, determinant becomes. So if two rows are interchanged, it is obvious that the determinant becomes negative. This is because swapping rows changes the sign of the determinant. Number 72. If two rows are identical, the determinant is A 1, B -1, C 0, or D undefined. The correct answer for number 72 is letter C. It is because identical rows make the determinant 0. Number 73. Which condition guarantees that the determinant is 0? A. Diagonal matrix. B. Two proportional rows. C. Identity matrix. Or letter D. Upper triangular. Number 73 is letter B. This is because proportional rows result in a zero determinant. 73 is letter B. Proportional rows or identity matrix result zero as its determinant. Number 74. If determinant A equals -2, find that A to T. The correct answer for number 74 is letter B. It is because the determinant of A transpose is equal to the original determinant. So letter B, which is -2. So if determinant A equals 4, this is for number 75 already. Again, if that or determinant A equals 4 and determinant B is equal 3, find the determinant of matrix A times B. So this will be simply multiplied. So number 75 answer is letter B. So this is simply 3 times 4 and that is 12. So our answer is letter B. Number 76. Which matrix always has determinant 1? A 0, B identity, C diagonal, D symmetric. So a matrix that has always have 1 as its determinant is the identity matrix, which is letter D. Number 77, which operation does not change the determinant? So the operation that does not change the determinant is the add multiple of one row to another, which is from the option C. This is also because adding a multiple of one row to another does not change the determinant. Number 78. If a matrix has a zero row, determinant is. So if a matrix has a zero row, it is obvious that the determinant is 0. So the answer is letter C. Number 79 question. If the determinant of A is not 0, system AX is equal to B has A no solution, B infinite solutions, C unique solution, D trivial solution. So the correct answer for number 79 is letter C. A non-zero determinant implies a unique solution. It's letter C. It's because the determinant is non-zero, so of course, the system has a unique solution. Number 80. If matrix A is 3 by 3 and each row multiplied by 2, the determinant becomes A 2 determinant A, B 4 determinant A, C 6 determinant A, D 8 determinant A. So the correct answer for number 80 is letter C. This is because scaling rows affects the determinant proportionally. So number 81, which matrix has determinant equal to the product of diagonal elements? So the matrix that has determinant equal to the product of diagonal elements is the triangular matrix. This because this talks about product of diagonal elements. And as far as we can remember, a triangular matrix can be solved by the product of the diagonal elements. So literally, the answer for number 81 is letter B. Number 82. If determinant A times B equals 0, then A, determinant A is 0 only, B, determinant B is 0 only, C, at least 1 is singular, D, both invertible. So number 82 is letter C. If that A times B equals 0, there at least one matrix is singular. And that is our number 82. Number 83. If two columns are equal, a determinant is. So to emphasize, if two columns are equal, what would be the answer for its determinant? So A is 1, B is -1, C is 0, D is undefined. So By calculating the determinant, if two columns are equal, the right answer for number 83 is letter C, which is 0. And this is also because equal columns make the determinant 0. Number 84, let A and B be 3 by 3 matrices such that TR A equals 5 and TR B is negative 2 and transpose AB equals 4. Which of the following is always true? So the correct answer for number 84 is letter B. Transpose AB equals to transpose BA. Number 85, let A and B be invertible matrices of the same order such that transpose AB equals A transpose B transpose. Which of the following must be true? The correct answer for number 85 is letter D. No conclusion can be made. The statement is generally false. So by reviewing my answers from this discussion, I have found that I have made several mistakes, and it paved the way for me to learn more about linear algebra and matrices. And I have learned and now remember that if the determinant is 0, then some method or most of the method will not be able to be applied because it has to be that the determinant must not be 0. And I also learned that the most helpful method is the Gauss-Jordan, not on Cramer's rule because Cramer's rule cannot handle heavy solutions. And it gives me more learning about matrices, its inverse, its transpose, the determinants, and many more. And it's just so amazing that many methods can be applied and that I get to have the joy in doing different operations from these methods for matrices. And that would be all for my discussion from the correct answers of the midterm examination in linear algebra. Thank you so much, Ma'am Normina Batukan. God bless.